Okay, let's look at this sample paper question, that question number 28. So this question is based on uh, naive Bayes classifier, and we have to look for that total number of parameters given the class and given the features, and uh, in feature how many values are there, everything is given. We have to find that how many parameters is need to be estimate for the naive Bayes classifier, right? So let me read out the question. So question is given a k class dataset containing endpoints where sample points are described using d discrete features, with each feature capable of taking v value. How many parameters need to be estimated for the naive Bayes classification? So if you have already gone through the theory of this naive Bayes, so what I am considering is that this is all these. So let me first of all, uh, so we have total k classes, right? So we have total k classes, and we have the feature vector x, that so we have total, that if we form, so it will be a matrix, right? And it will have how many column vector it will have? It will have a d distinct feature. So d distinct feature may be that x1, and this will be x2, and here xt. So we have this d distinct feature, and each feature is capable of taking v value. So we will have how many rows? That row will be v, right? So this matrix will be v cross d, right? So the size of this matrix will be v cross d, right? And now let's look at this, first of all, this Bayes theorem. So at the time of prediction, or at the time of test time, what we do, we need to have the info of the prior probabilities and maximum likelihood. So what do I mean? That we need to have the probability of all the classes, right? And at the testing time, or we can say at the prediction time, also what we need is the prior what we need, so this one is the prior probability that we need, and what we need is the maximum likelihood, that is the probability of uh, this x given under the condition k, right? So if we know these two, then during the test time, if we know these two thing, then during the test time we can easily calculate and classify the data, right? Okay, now we have to find that how many actual parameter do we need. That is the question, right? So you see that first of all, to cal so so how many this prior probability will be there? There will be k prior probability, right? Because for each class you will find the probability. So we have n classes. So for we have k class, so for each class you will find the probability, right? So you need to have the info about the k prior probabilities. So this will be k. So like this one, uh, so this will be k, right? So number of prior probabilities will be k. Now since this is naive base means uh, what we are assuming is the conditional independence. Conditional independence means that if you pick any element from this matrix X that has nothing to do with any of the other elements, right? So this red element is independent of any of the other element under this condition K, right? So this is the naive assumption that makes the naive base classifier is the naive, right? So 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 we need to calculate this one, right, under this conditional independence assumption, right? So how many this maximum how many this probability how many probabilities do we need to calculate, right? So we have how many elements, for each element we are going to calculate the probability, right? So we will be having v into d, right? That number of element we will have, and under this condition k we are going to calculate, right? So for each condition, right, we are going to calculate. So total number of parameter will be k plus uh, vkt. So k plus vdk. So this is the total number of parameter we need to know. If we know these number of parameters, then during the test time we can make use of these parameter and we can classify our uh, evidence or the given example or the given test example, right? So the correct answer for this 28 is option C.